Welcome to today's class. It is from higher secondary second year aldehyde and ketones, and today I have just chosen a very small unit preparation, and I have solved out all competitive exam questions answer, and it is very important point which I am going to start today, and very often asked question from this one. So from preparation of alkane, let me first explain some of the important reagents. You must have knowledge on reagents. So oxidizing and reducing reagent. The reagents which are generally used for the preparations of aldehyde and ketones will be discussed here. Number one, PCC, Collins reagents, NO2Cr2O7, K2Cr2O7 and KMNO4. First of all, I will take, and reducing one is DIBAL, and I will just talk about a bit on PCC. What is PCC? Chlorochromate. And very often the name of the reagent or structures is asked in the exam, entrance exam. That's why I have given it pyridinium, and along with this is plus, and along with this chromate, chloride, chlorochromate. This is pyridinium chlorochromate. Why it is so important? First of all, it is selective. Means does not affect on the reactant if there is any double bond. Double bond will remain intact. Hence, it is selective. Number two, it is mild. Means on oxidation, generally a trick is that I will just discuss about the trick. Trick is that CH2OH group will combust to CHO, and on further oxidation it becomes COOH. Since it is mild, it stops this up to CHO and doesn't undergo any further oxidation. Hence, it is very important. And another important is does not affect upon double bond. If in the structure of the reactant, if anywhere there is double bond in the chain, it doesn't affect double bond. So due to this nature, pyridinium chlorochromate is very important. So I will discuss about this thing. It is a oxidizing agent, and second one is DIBAL. What is DIBAL? Trihydride H, and it is very often it is named as DIBAL. In the arrow above, DIBAL will be given. It is a reducing agent. The information, it is reducing agent, and very important, and for entrance point of view very important. And second one, it reduces to aldehyde. Since I am not concerned with nitrile here, I will not do this one. I will do only aldehyde because I am concerned with the aldehyde. So this is all about the DIBAL. And if you talk about the structure of DIBAL, so this is in short, the structure is so diisobutyl aluminum hydride. This is simple information you need to know before starting, and this is full of trick. You need to know much of this. So I am concerned with the aldehyde and ketones preparation. First of all, I will prepare alcohol. From alcohol, I will use PCC, pyridinium chlorochromate. So simple answer is the shortcut CH2OH, and it is mild. It will stop here. It will not further go to this part. CH2OH becomes CHO, then this. You learn it. You should learn it. So this will be simple. CH2 becomes CHO, and it is a mild. PCC is a mild oxidizing agent. So it will stop here. It will not further oxidize to COOH. Now, how it has done? If you want to know this thing, you will be very happy that chemistry is full of trick. Let us show it. So since oxidation will occur. We'll talk about PCC. Am I right? Oxidation occurs. So what happens? You see the trick means loss of hydrogen. How hydrogen will be lost? You see, one hydrogen will be lost from oxygen, and another hydrogen will be lost from oxygen attached to carbon. From that carbon, one hydrogen will be lost. What you get here is H. Am I right? CH3COH. You make it double bond. Okay. Very excellent method. Take in the example, and you will be confused how to do. Again, you remember loss of hydrogen. Two hydrogen will be lost, one from oxygen, other from hydrogen of the carbon adjacent to oxygen. So you see, and this is one hydrogen, am I right? And this is carbon adjacent to this oxygen. So there is a hydrogen. So we lost the way of losing hydrogen means one hydrogen from O, another hydrogen from carbon attached to O, and that bond will be withdrawn here. Your answer is very easy. It is full of trick. Mind that it is not mechanism. It is trick. Say you are given. Now, it is a reducing agent. It is a reducing agent. And its function is, earlier we have lost electron. Here we will add electron. Add hydrogen. So aldehyde. We take an example of ester. Say RC, hardest. This is ester. RC double O hardest. This is ester. So what we are using here is diibal. This is DIBAL-H. Am I right? Whenever there is DIBAL-H, there is water. 1 and 2 water is there. I have not written. It is implied water is there. So what is the trick? How will get? No doubt we will get aldehyde. How will you get aldehyde? You can't imagine how will get. So you see the way of writing, the style. OH in this way. So our main trick is to add hydrogens. Am I right? It is reduction. So one hydrogen should be to carbon and other hydrogen to O. So we will add O. It is trick, not mechanism. One is here, hydrogen is here, and other hydrogen. Am I right? The same way, hydrogen was removed. One from O, other from C in oxidation. Here reduction, it will be added. One to oxygen, other to carbon. The way how we will get it is a trick. So you just break the bond here. Am I right? So you are getting R C double bond H, this part, and that part is hardest OH. You have got aldehyde. Am I right? One example. In the exam you are given DIBAL-H. What will you do? What is the trick to get the answer? The trick to get the answer, one hydrogen here, other hydrogen here. So efface it out. So you break in this way. So what you, that is X ester, From extra we have got aldehyde. So it is very beautiful way we can get the answer. Otherwise you can't imagine how you will get the answer. You just understand the technique. Of alkyne. Here what reagent will be given above the arrow? You keep it in your mind. This is the reagent. Diborane, hydrogen peroxide, potassium hydroxide, sodium hydroxide, a base. That will be in above the arrow. That means there will be hydroboration of alkyne, and that alkyne will give rise to aldehyde. How will you get? Very simple way I will show you. So reagent are base. So you see the way how you get, I am showing you. This follows anti-Markovnikov's rule. Say you assume here CH3. Here no hydrogen and here hydrogen is there. So OH should, according to Markovnikov, OH should have attached here and H should here. But since the main striking point is that it is anti-Markovnikov, you do how to get the result. This is the trick, not the mechanism. If you see the this is one hydrogen. Yes, here we see that as per anti-Markovnikov rule, negative part of that is OH will get attached to the carbon having more hydrogen. So OH is here and positive part is opposite to double bond. So now this is unstable. This goes to this part and this inclined here. We get this one. So what we get here is, say, the shortcut. The shortcut is, this is all about the reaction, very important. The shortcut is if B2H6 and hydrogen peroxide and OH is there, and if it is acetylene, if both carbon are having same hydrogen, then in one part, any part you add H2, and where there is CH, this part will become CHO. So we have done H2 CHO. This is shortcut. Now if you see that carbon has difference in number of hydrogen. Here one hydrogen, here CH3, no hydrogen is there. So and the opposite carbon will get two hydrogen. So we have written CH3, and that has come with C2 hydrogen, and CH will become CHO. Always CH will become CHO. Now next case I have shown you where both the carbon are having no hydrogen. Now which part will be CHO or CO? If there is CH, it will be CO, and if there is no H, CHO. If there is no H, it will be CO. So here CH is there, it becomes CHO, but here in this case no hydrogen is there, means one hydrogen will be less. One hydrogen less means CO. So out of these two, somewhere there will be CO because there is no hydrogen. But question, which part will have CO and which part will have H2? One part H2, other is CHO, or one part H2, other part CO if there is no hydrogen. So one part must have CO, and which part will be CO, that will determine by the alkyl part. This is ethyl and this is methyl. Ethyl has more plus I effect. So your more plus I effect is here from on this carbon. So this carbon will CO, will be CO. This carbon will be CO, and opposite carbon will have two hydrogen if the inductive effect is in this direction. So we have written CH3, and this carbon is CO, and that carbon is H2. So that carbon we have written H2, and CH2 will remain same. So this is the trick of diborane, hydrogen peroxide and OH. How we will get the same trick is applied if there is double bond. If there is double bond, then this will be alcohol. I will discuss it in another class. Now last part of today's class is hydration. Now that hydration of what? Alkyne. That hydration of alkyne. Now how? Here you will get HgSO4 and sulfuric acid and water. These are the reagent required for hydration. So let us take one first. It is again interesting. C triple bond CH, where hydrogen is same, we assume Hg 2 plus, sulfuric acid may be written in this way, and there is water. Answer, let me write in details, then you will get it. Here we need to add H and OH. So by Markovnikov rule or whatever rule you apply, you will get whatever place you add OH and H, it is all the same. Say let OH is here and other H is here, because it is symmetric, it is not unsymmetric. So what will happen? This is again unstable. So that bond will withdrawn here. So you are getting HC double bond C H H, and if this bond goes, this hydrogen goes with bond here, so this will be inclined here. So you are getting that is CH3CO. So what we get here is whenever there is CH, that CH becomes as earlier we can write one part will be CHO, that CH will become CHO, and other part will have two hydrogen attached. So one hydrogen is there attached to hydrogen, it will be this. So one part H2 and other part CHO. Am I right? So we will not do anything. So you see the trick is that CH3 C triple bond CH, the same reagents are there. So since it is, what will happen here? Markovnikov rule will appear, not anti-Markovnikov, diborane anti-Markovnikov. Markovnikov rule appears, OH and H. So H will get attached, less carbon, less hydrogen, more carbon. So OH will attach to that carbon which has less number of hydrogen. So here OH will be here, and in place of triple bond it will be single bond, and one hydrogen will be attached here. Now it is unstable, so we will do this, and this bond will be withdrawn. What we get here is CH3 C double bond CH3. So the rule is again the same. What we get, the trick, what trick we get as earlier as diborane, but it is not anti-Markovnikov, it is Markovnikov. In case of anti-Markovnikov, OH would have attached to the this one. In case of diborane, this one, and H this one. This is just different. So CH3 C triple bond CH Hg 2 plus H plus water. What's happened? You see, that is less hydrogen, carbon having less hydrogen will become C. No hydrogen is there, it will not be CHO, it will be CO, and hydrogen having hydrogen, this will be not CHO. CO is already this, and this part, if it is CO and that another part is hydrogen. So one part is hydrogen CHO, if this carbon having same hydrogen, and here it has no hydrogen, so this will be CO and other part will be H. You add just H2 as earlier. So you are getting this. So without any rule, by trick you can use this one. This is called hydration of alkane. So we are getting aldehyde and ketone. Very important, very often asked in the entrance. This question is asked. Very important. So it is nothing but oxidation. Oxidation. How? What is oxidation? That times I told you, oxidation is loss of hydrogen. Reduction is addition of hydrogen. So since it is oxidation, there will be loss of hydrogen. Let us take one example of 2 degree alcohol, 1 degree alcohol, and you give copper and 300 degree centigrade or 573 Kelvin what we get here is loss of hydrogen. So one hydrogen will be from here and other from oxygen. So you are losing out two hydrogen. What you are getting? CH3 CHO. So you just simply get CH3 CHO. This is over. Now go to the second one, CH3 CH3 H, second degree. This is second degree alcohol. Give the same reagent. So one hydrogen from here, other hydrogen from, one from oxygen, other from attached to carbon. Carbon attached to oxygen. So what you get here is CH3 double bond O. You are getting ketone. So you have got 3. But the tremendously important fact here is that if it is 3 degree alcohol, what happens? Just you see CH2 H CH3 double bond alcohol. It is 3 degree alcohol. So copper 300 degree centigrade. But in this case, the fact is that elimination occurs. No hydrogen, oxidation in place of oxidation, hydrogen and hydrogen will not be eliminated out. Here, these two will combinedly gives, and that bond is inclined in this way. You will get CH3 C double bond CH2 CH3 plus water. So the question very often asked in the entrance exam is that, so 1, 2, 3, 2 methyl propane tool when passed over copper at 300 degree centigrade. Answer, what is the product? Answer, 2 methyl propene is produced. And this is the question very often asked. This is all about the today's class. Thanks a lot for watching the class, and please don't forget to subscribe the class.